Okay, so hello everyone. Thank you for the introduction. Today I want to present to you some of the results of the demographic analysis that we have been doing as part of our project MEMBRA, specifically related to the regeneration of mature woodlands in the UK. So, just for context, there are over 2 billion trees in the UK as an estimate, which might seem like a very large number, but in fact, all of these trees are contained in just over 10% of the UK's land area, and that number is even smaller for mature woodlands or ancient woodlands, which cover only about 2.5% of the total UK area and less than half of that number of trees. And why does that matter? It's because these mature woodlands, they are the ones that are more efficient and more resilient and that provide the ecosystem functions that we know that forests are expected to provide, such as functioning as a carbon sink, providing biodiversity associations that might serve as biodiversity sources for new expanded woodland areas, and a range of ecosystem services such as flood control, and also a range of cultural values from different cultural aspects, as David was presenting earlier today, both in terms of religion and in historical cultural values of this country as well. So mature woodlands, preserving the mature woodlands should be seen as being as important as expanding the woodland area, the total woodland area in this country. And preserving them means that we need to make sure and understand if their regeneration process is functioning correctly, because the only way that these woodlands will self-sustain is if they are producing enough trees that establish and survive to become the adult trees to replace the old ones that are there. Now, the issue is, we know that most of these woodlands in the UK are under increased disturbances, both from historic management, uncontrolled population of herbivores, climate extremes, pathogens, and also urban developments, which are still resulting in the deforestation of these very rare and precious woodlands. And all of these pressures can very well affect the demographic process of the forests and interfere with their regeneration, potentially compromising their future persistence. So we, as part of MEMBRA, wanted to determine if these disturbances were severe enough to cause a disruption in the demography of the regeneration of the forest that would put it in a position that is beyond what is expected from natural variability. And we were able to do this because we had a very unique data set of 10 different sites in Great Britain. So these are the locations of our sites. And beside the locations, we have a timeline of dates when these sites were visited in the past by various people that started this monitoring, this long-term monitoring, and people that continued this long-term monitoring. So at every visit, people went back to the exact same location and to the exact same trees. They were all mapped. They are now all tagged as well. So you can track the future. So you can track the history of a tree in this data set, when it first appeared and when it died. Each of these woodlands is very unique. So some of them are monodominant, so some of them are mixed species, some of them were planted in the past, and others will have no idea how long they've been there. And so together they provide a very comprehensive data set of different woodland types in the UK. And we visited all of these sites again in 2022. That's the only straight vertical line of visits that you can see there, where we measured about 6,000 stems, both dead and alive. And with this most recent survey, we have completed for all of the sites at least 3 points in time, which allow us to compare the number of new trees that were coming up in the past with the number of new trees that are coming up now, and also the same in terms of mortality of these trees. And these are some of the results that I want to show you now. So here we have 2 time series. So in each of these graphs, I am showing As a black line, one of our sites, and the dots are the survey dates. And on the left, on the graph to the left, we have the mortality rates of small saplings, and on the graph to the right, we have the mortality rates of large saplings. So the small saplings are the ones that are less than 5 centimeters diameter, and the large ones are the ones that are that are more than 5 centimeter diameters. And the thing that we can see immediately here is that over time, the mortality rates of these saplings is increasing, and the recruitment rate, which is just the number of new recordings, is decreasing over time, which is very indicative of a loss of regeneration capacity in these forests. So you might notice on the graph to the left that there is one site, that's one line that's going up. That's the only site where we haven't seen a decline in recruitment. That's a monodominant birch forest in Scotland. Now, of course, because of this decline in regeneration capacity, we also see a very sharp decline in the number of small saplings, especially up to 80% reduction in the number of small saplings, and a slightly lower reduction, but still significant, in the number of large saplings in these woodlands, which means that the forest is probably not producing enough trees to replace the old ones that's there. Now, to some extent, this is expected because as we expect the forests grow through time, and as they grow, the canopy closes, and then the trees have a harder time to establish, they die more. So we wanted to try to separate these effects of forest structure to try to estimate to what extent these results could be expected. And the first thing that we see, that we looked at, is actually how much is the forest structure changing in these woodlands. So in this graph here, what I'm showing is something that's analogous to a self-thinning line, which is basically a log-log association between the number of trees and the size of the trees in the woodlands. So in very simple terms, on the top left, you would find a woodland that's very young with numerous small trees, and on the bottom right, you would find a woodland that's more mature with larger trees. Each of these arrows represents one of our sites, and what we can see is that through time, all of these mature woodlands are going through a predictable successional trajectory that's associated with an increase in size of the trees and a decrease in their numbers. So they are going through a successional trajectory, which should affect some of those results that were shown. However, we tested this effect using mixed effect models, and we find that it exists, but it's very small. The effect of the large tree sizes on regeneration is there, but is not strong enough to explain our results. And that's basically because the structural change is very small. The trees only grew by about 2.5 centimeters over diameter over the past 40 years. And that's not a very significant structural change to affect the size of the canopies and to cast a bigger shade on the trees that would make it harder for the trees to establish. What this also doesn't explain is a certain element of synchronicity that we see across all of the sites. This might not be so easy to visualize here, but in some of the sites, we were seeing that there was a certain increase in the number of the trees before 1990, before 2000, or that the number was not changing, but after the 2000s, then all of the number of trees starts going down across all of the sites. And that cannot be explained by succession because these sites are very distant from one another and they're very unique, and you don't expect that to happen across all of them at the same time. So if succession doesn't explain these results, we then moved on to try to test if there is an element of climate conditions that could be explaining this. So we tested the effects of temperature, precipitation, and dryness during the census intervals, and we see that there is indeed also an effect, especially of summer temperature, as being detrimental to the regeneration capacity. This is, I'm showing this on the left, on the two left graphs. The top one is the mortality in the plots, and just for showing this, I've transformed this, I've standardized the data just to see that they're all going in a similar direction. And on the x-axis, you have the summer temperature, and you can see that the mortality increases with the summer temperature. And on the bottom left, what we can see is that the recruitment decreases with the summer temperatures. And as a consequence, what we are also seeing is that there is an increase over time of the drought tolerance of the regeneration community. So of all of the trees with diameter between 5 and 10 centimeters. So summer temperatures are usually associated with the occurrence of heat waves and droughts. And for that reason, we would expect that if they have a detrimental effect over the regeneration capacity, that the drought tolerance of those trees would increase. However, this effect is also not strong enough to explain the sharpness of the declines in regeneration capacity that we saw. So we moved on to try to find other factors that might be influencing. And even though we don't have enough data to estimate the effects of these drivers, one of the obvious candidates is pathogens. So 4 of our sites are ash-dominated, and ash dieback disease kills young trees very fast, much faster than it kills adult trees. So that's definitely one factor that's compromising the regeneration capacity of these woodlands. Powdery mildew is probably one as well, which has been here for much longer than ash dieback disease. However, it's expected to become more severe with warmer winters and wetter conditions. So it could be playing a role in the synchronicity of these declines that we saw as well. And lastly, these are maps of deer ranges in the UK, and each map is showing one deer species, and the brighter colors, they're showing the most recent deer expansion between 2002 and 2007. And what we can see is that recently there has been a rapid expansion in deer populations in the UK, which is certainly very detrimental to the forest regeneration and could also be contributing to this synchronicity element of these declines in regeneration. So in summary, our results suggest that there is an ongoing recruitment failure in these mature woodlands of the UK, which are unlikely to result from forest succession alone. There is an element of warming temperatures as one of the factors that's hampering this regeneration capacity, but this is also not the main factor that's explaining this, and we suggest that pathogens and probably herbivores are also contributing to the more severe aspects of these regeneration declines. That's it. Thank you very much.